All right, folks, we're going to move on with 6.2, Part 2. And we're going to take a look at about 3 or 4 more examples and hopefully try out a few new cases, okay? So we'll take a look at example 4. We have cosine of 2x minus pi over 4 equals 0. Now this time, though, I want us not to list all the ones or one time around a circle, but I want us to list all possible solutions. Now, what's going to be helpful with our all possible solutions is we're going to use the idea of this 2 pi n to help us, and it's actually going to be a little bit easier than what I asked you to do in example 4, okay? So, let's get started. We've got cosine of something, and so I'm going to go ahead and say I want to make a u substitution. I'm going to let u equals 2x minus pi over 4, which means everywhere I see 2x minus pi over 4, I'm going to go ahead and put a u. So I will get cosine of u equals 0. And how do I get rid of that cosine? I'm going to go ahead and arc cosine both sides, or inverse cosine. So inverse cosine both sides. And again, I'm not writing that on the left-hand side because I know they're going to cancel out, and the purpose is to get the u by itself. And so let's take this and let's translate it. This says find an angle with an x value of 0. So we're going to go ahead and look at our unit circle. Where do we have a x value of 0? And we're going to find that this point up here and this point up here both have x values of 0. And so if we write those down, we're going to notice that one of them is going to be pi over 2, and the other one is going to be 3 pi over 2. Now, normally with cosine, I would add a plus 2 pi n and a plus 2 pi n. But that's actually going to give me some of the same answers. And so what I'm going to do is, instead of adding 2 pi, I'm just going to add 1 pi. Because from here to the bottom half of the circle is the same as adding plus pi. And so that'll just give me both points in one equation rather than having to write 2 separate equations. So I can say x equals pi over 2 plus pi n. And I still want the n there because I want to think about all of the different possibilities that I can count all the way around the circle as many times as I want. All right. Now, I actually did something I definitely don't want you to do. I don't want us to use x's. I want us to use the u's in the u substitution that we made. Okay, so when we have these u's, we need to go back and find the x value. So I'm going to put a little divider here. We're going to take this formula up to the top, and we're going to set that equal to u. So we've got 2x minus pi over 4 equals pi over 2 plus pi n. And again, n is just an integer. And sometimes you see that written n is an element of the integers. Some textbooks use fancy script z's. I just write a second bar there, call it a day, okay? But now what we are going to do is go ahead and solve for x. So I'm going to start off by adding the 2 pi over 4 to the other side. So I will get 2x equals 3 pi over 4 plus pi n. And now I'm going to divide by that 2, and I'll get x equals 3 pi over 8 plus pi over 4 pi over 2n. Now, if I want you to list all the possible solutions, that's your answer. That's it. Okay, you can leave it like that, and I will know that for every integer value of n that I plug in, it's just going to give me another possible solution. If you wanted to list out the ones from 0 to 2 pi, I believe you'd get 3 pi over 8. You would get 7 pi over 8. You would get 11 pi over 8. And I believe you'd get 15 pi over 8. And that would be your solutions just one time around the unit circle. It's not a bad thing to practice plugging in numbers for n to try and get these different answers down here. But if you want all possible solutions, you can stop right here. Okay. Example number 5. This time we have one that has a sine and a cosine in it. Okay, so this is starting to look at some kinds of questions which are going to ask us to do some factoring. Okay, now before we factor though, what we have to do is we need to go ahead and make sure everything has the same trig function. So I don't want to mix the sines and the cosines. I want everything to be sines, or I want everything to be cosines. But one thing I'm going to remember is that in 6.1 we talked about trig identities, and one of those was this one, sine squared x plus cosine squared x equals 1. Now I see a sine squared x, and so that's making me think I'm going to subtract that cosine squared to the other side, and everywhere I see the sine squared, I'm going to put 1 minus cosine squared. So that's going to give me 2, 1 minus cosine squared x minus cosine x minus 1 equals 0. And now I have a case where if I distribute, I'm going to get 2 minus 2 cosine squared x minus cosine x minus 1 equals 0. And so everything now has cosine or cosine squared, which is good because now I can use factoring. Now I'm going to clean this up a little bit. I'm going to move everything to one side, set it equal to 0, and I like for my squared term to be positive. So I'm going to move everything to the other side. I'll get 0 equals 2 cosine squared x plus cosine x minus 1. And this one is factorable. 2 cosine x will give me the 2 cosine x squared. 1 and 1 will give me the 1 at the end, and I need it to be plus 2 and minus 1 to give me the minus 1 at the plus 1 in the middle, sorry. Okay, now we can set both parts equal to 0. So I'm going to take this part. I've got 2 cosine x minus 1 equals 0. That's going to tell me that cosine x equals 1/2, or that x equals arc cosine of 1/2. And when I go to my unit circle and find out where this is, I realize that that is true at pi over 3, and it is true at 5 pi over 3. So there's 2 locations. Now if I take this other factor, I'm going to move it up here, and cosine x plus 1 equals 0. I know that cosine x equals negative 1, and that x equals arc cosine of negative 1. And when I look at my unit circle to find an angle that has an x value of negative 1, I get pi. So I've got these 3 answers, and it looks like I've gone all the way around the unit circle. And if we said let's find all possible solutions, here's what we're going to do. We're going to take each of our answers and we're going to throw a plus 2 pi n on the end. That will say that we just keep going around the unit circle as many times as we want to. So that's going to mean that we have x equals pi over 3 plus 2 pi n. X equals 5 pi over 3 plus 2 pi n. And x equals pi plus 2 pi n. And these three statements give us our three variations of answers. Okay, example number 6. So, I see this squared, and I'm thinking maybe I need to factor, and in this case though, it's actually going to be okay to have a sine squared and a tangent in the same equation, because what I might notice here is that this first term has a tangent, but so does the second one. So I can go ahead and take the tangent out as the greatest common factor. And then I can go ahead and factor the 4 sine squared minus 1 into 2 sine x plus 1 and 2 sine x minus 1 equals 0. And that we saw in an earlier video, this pattern of a squared minus b squared factors to a plus b times a minus b. And that's a good one to look for. It's really helpful when we're factoring. Okay, now in this case, I have 1, 2, 3 terms that I need to set equal to 0. And let's say that we're looking again for all possible solutions. So I'm going to set each one equal to 0. So tangent x equals 0. I'm going to set 2 sine x plus 1 equals 0. And I'm going to set 2 sine x minus 1 equals 0. And then I'm going to solve each equation. So here I have x is going to equal arctan of 0. And so I'm looking for where the y over x value gives me 0. And that's going to be at 0. And it's going to be at pi. And I can generalize that by saying x equals 0 plus n pi. So here is one of my solutions. The second equation will give me sine x equals negative 1/2. And when I look on my unit circle to find out where there are y values of negative 1/2, I'm going to get 7 pi over 6, and I'm going to get 11 pi over 6. Now we're going to wait until we solve the third equation to write out our general solutions for the sine part. So in this case, I'll get sine x equals 1/2, or where on the unit circle do I have y values of 1/2? And I'm going to find out that I have that at pi over 6 and at 5 pi over 6. And the reason why I wanted to wait to write my general solutions for this is because I might notice another pattern, which means I don't have to write as many equations. And so I noticed that to go from pi over 6 to 7 pi over 6, I'm just adding pi. And if I'm going from 5 pi over 6 to 11 pi over 6, I'm just adding pi. So I can combine those into the same general form. So one of the general forms will be x equals pi over 6 plus n pi. And the other one will be 5 pi over 6 plus n pi. So I've got two solutions here, and then one more down here, which gives me a total of 3 possible sets of solutions. Okay, let's take a look at our last example here. And we're looking at a case now where we have something called multiple angles, or 2x instead of just an x. Now this one is actually nice in the sense that it's already set up factored for us. So we don't need to factor like we did in question 5 and question 6. And so I'm going to go ahead and take cosine 2x and set it equal to 0. And separately, I'm going to take secant 2x plus 2 and set that equal to 0. I'm going to use the idea of the u substitution. So u is going to be 2x here, u is going to be 2x here. And let's see where that takes us. Cosine u equals 0. Or u equals arc cosine of 0. And so where on our unit circle are the angles equal to, where do the angles have a x value of 0, and we get pi over 2 and 3 pi over 2. Now because we're doing our u sub, we need to say 2x equals pi over 2 and 2x equals 3 pi over 2. And since we're going to do general solutions, I'm going to go ahead and add our 2 pi n and our 2 pi n. And now I'm going to go ahead and divide everything by 2, so I'll get x equals pi over 4 plus pi n. And when I look at the second one, I will get x equals 3 pi over 4 plus pi n. And so this will give me one solution set. This will give me another one. And I've still got a few more to find from the secant one. So let's go back to that secant. Okay, if we make the same u substitution here, we'll get secant u plus 2 equals 0. Or we'll get secant u equals negative 2. Now, I don't know about you, but for me, it's harder to think about secant, but if I know what the reciprocal is, then it's a little bit easier for me to find numbers on the unit circle. So what I'm going to do is I'm going to find the reciprocal of this side. So secant u, the reciprocal is 1. The reciprocal of secant is cosine u. But if I find the reciprocal of the left side, I also need to find the reciprocal of the right side. And so when I flip negative 2, I get negative 1/2. And that's what that question is really asking us here, is can you find an angle that has x values of negative 1/2? And so when we look at our unit circle, we're going to realize that u could be 2 pi over 3, or it could be 4 pi over 3. Now, we want to make sure that we solve for x, so I'm going to say that 2x equals 2 pi over 3 plus 2 pi n, and that 2x equals 4 pi over 3 plus 2 pi n. And I'm going to divide both sides by 2, so 2 pi over 6 plus pi n, and 4 pi over 6 plus pi n. And you were more than welcome to reduce, so you get x equals pi over 3 plus pi n, and x equals 2 pi over 3 plus pi n. And so here we finish our last example. It has the most number of solutions out of all the ones we've seen, but it's okay for it to have a lot of solutions when you solve a trig equation. Okay? If you have any questions, let me know. Shoot me an email, send me a message on Canvas or through WebAssign, and I'm happy to help you